Okay, so we learned what supervised learning is and why do we need supervised learning. Now it is about how. You might tell me, okay, I got it. Supervised learning is about learning the association between the predictors and target variable. We want to use supervised learning for sake of prediction because we want to be prepared or we want to intervene. But how actually this learning of association happen? I try to address this how on a very broad and general level, yet enough for your understanding. And the reason is there are many different methods for supervised learning and their mechanisms are different. So I need to introduce you to a general mechanism rather than going through the details of specific algorithms. And also, I don't want to get very mathy, very computer science style in order to address the how. So let's go through it. We want our methods to learn the association between predictors and the target. How does the method, learn? Well, by optimizing its parameters. So for instance, this is a association. Okay, this is a general form of a association. This is the association between income as the target and education years and work experience in years as the predictors. So our algorithm specifically now is in a simple form of a linear model. It says that income is somehow equal to a parameter 1, which is a constant, parameter 2 multiplied to predictor 1 plus parameter 3 multiplied to predictor 2. So in a linear fashion, in a mathematical formulation, I have associated the income, the target, to the two predictors. But the point is finding these parameters. This is the actual learning. How are these related? You might say that the P2 is equal to 0 and P3 is equal to 0, and then income is regardless of the years of education and years of experience, and P1 is equal to 30K. So your model for every new case would predict 30K as the income. This is not a good model, right? You get it. You might say that, okay, this is not the way. While the P1 is 10,000, the P2, the number of years, let's say number of years of education, let's say it is 2, and the number of years of experience, it is 3. So the experience is more important than education. In that case, you will say that your model is like 10K plus 2 predictor 2 plus 3 multiplied to predictor 3. So for a person with 10 years of education and 1 year of experience, it would be, and let's say that these are not 2 but 2K and 3K, and this is, let's say, 10K. So the income would be for that person 10K plus 5 years of education, good, plus 5 multiplied to 10K plus 1 year of 1 year of experience, good, 3K, 23K. This is your prediction. So the goal is finding these parameters. This is the key, finding the best parameters. And this finding is learning. The algorithm finds these best parameters from your data. And this is why we say that the algorithm learns from the data. Cool. So this mechanism actually is not something important for now, especially in the scope of this week. But I explained it to you in order to give you some impression. While all methods try to learn such association and finding these parameters, in general, the association. So let me clean up a little bit. Some learn it better than others. So some algorithms, some methods are better in learning for a specific problem than others. The thing is how we measure this goodness. We measure the quality of learning by quality of prediction. We say that, okay, you learned very good when you predict something very accurately. These best parameters are found when the prediction quality is maximized. So learning quality is something that we have to measure. It is like the quality of fit for clustering, for unsupervised learning, if you recall. And we don't measure it directly, but we measure it based on prediction quality. So if you recall, I talked several times about accuracy of prediction, of prediction, and this is exactly prediction of quality. So we need to somehow measure the quality of prediction. Somehow, with a metric, we need to measure it. Otherwise, how can we know that our method has learned properly? Imagine that you are coming to university and you claim that I've learned everything. And the thing is, university somehow needs to evaluate your claim, evaluate the learning quality. This is exactly the same story here. And this is the topic of performance assessment. Performance assessment, and there are many metrics indeed for this assessment. So let me clean up. To wrap up this slide, we talked that learning the association, and learning means optimizing the parameters. And different methods, they have different ways of learning, and not all of them are equal in learning abilities for a specific problem. So we need to measure the learning quality, how well they have learned from a data set. Therefore, we need a measure of quality of learning, and that measure is basically quality of prediction. We use quality of prediction as a proxy of quality of learning. And in a more jargon term, this quality of prediction, how to measure it, is under the topic of performance assessment for supervised machine learning algorithms. And there are many metrics for them. We will introduce you to one metric in this session. Okay, so before talking about the metrics and everything, we need to know more about the process. And the process is splitting our data. So maybe it is better to change the color. Okay, good. So if this is our data, and this is the column of target, and these are predictors, we split it into two sets. Let's say we take I'm not sure why it doesn't work. Let's say we take let's say we take this part here and this part here. We call this small part testing set or subset. We call the above one training set or data set. Okay? The method learns the association between predictors and the target from the training set. So learning actually happens here. We train our method on the training data set. So as I said, train is another verb for learning. Our method learns the association between the target and the predictors from the training data set. And then our method tries to predict the values of the target variable on the testing data set. Okay? So our model learns from the training and evaluated on the testing data set. So the quality of learning is evaluated on the testing set. The trained model has not seen the testing set cases, so they are perfect for measuring the performance. So you learn here from the training data, and then using the predictors of the testing data that all are new cases to our model because our model has not learned from them. We get a prediction and then we compare the prediction to the actual predictions to evaluate the quality of this prediction. So to wrap up, there is this data that we have and we want to work on. Okay, this data. We split it into two subsets, one called training set, the other called is testing set. We train our model on the training set. Our model learns the association from training set, the association between the predictors and the target. And our model is evaluated on the testing set. How evaluated? Well, we feed the predictors into our model and we compare its predictions to the actual predictions. Okay? To clarify, I want to use this example. It's very nice. I really like this similarity, this analogy. So, train and test split is to some extent similar to mock and actual exams. When you want to prepare yourself for an exam, especially those standard exams, there are some mock questions. You learn from these mock questions. You have the answers to these questions, and the learning happens here. But the actual evaluation of your learning, whether you have learned everything fine and well into a satisfactory level, we need to look at new questions, okay? And these new questions is an actual exam. So this is for evaluation of learning quality. This is exactly similar to training data set and testing. Indeed, let's assume that you have 100 questions and answers, and you are studying for an exam. So you might say that, okay, I take 80 questions randomly out of these 100, these questions and answers. I study these 80 questions and answers, and then I evaluate myself. I test my learning on the remaining 20 questions and answers. And this is exactly the concept of training and testing. So in this example, for evaluation of your performance on the remaining 20 questions and answers that has never been seen by you, you accumulate, you aggregate the marks of the questions that you have answered correctly. Okay, that's a metric. Actually, there are many performance metrics in machine learning, in supervised learning algorithms. And not for and we can categorize these metrics into two groups based on the two groups of problems of supervised learning. So it's time to learn that supervised learning problems and algorithms and metrics are twofold. We have classification problems and we have regression problems. So classification problems is when the target variable is categorical. And when the target variable is numerical, we have a regression problem. So let's come back to that churn data set. Here, the target variable is categorical. So this is a classification supervised learning. But let's say if we wanted to predict the final mark of a student, like students in a class, that final mark is a continuous numerical variable, and in that case we would have a regression supervised learning problem. So coming back to our slide, there are two different problems in supervised learning, classification and regression. And subsequently, we have two sets of algorithms for each of these classes. And we have different metrics to evaluate the quality of learning. So coming back to our example and review it, we divide our data set into training and testing data sets. It is like you have 100 questions and answers like mock, and you want to prepare for an exam. So it's better to divide this 100 to 180 set and learn from that 80 and then evaluate your learning on this 20. This is exactly the concept of training and testing.